So we've talked about relations and functions and graphs. Now, we defined a function as a relation in which the domain does not repeat because the relationship between the inputs and outputs, the independent and dependent variables, are consistent. An independent variable is the x value. We've talked about this already, and you guys also covered it in science. It is the domain. It contains the values in the independent variable are all your inputs, your x values. The dependent is the range. It's the output. We talked about how to graph or how to represent functions. We said you can represent a function by using, or a relation, by using a table. And you can look to see within that table if it is a function, if the domains do not repeat, like in this instance they do not. And you can look at it by making a map where you list the domains on the left and you list the ranges on the right from least to greatest, and you draw arrows to go from the domain to the range. You can also represent functions as equations. Now, I used to always get very confused because I would always look at this right here and I would see f parentheses x and I would think it was some crazy calculus stuff. The only thing that this is saying,
it says my thing's restricted,
is the fact that what this is saying is that the function of x. Now think about what the word function means. Function kind of means like to work. So this equation is just simply a way of saying the way that x is going to work is by using this. When you see f parentheses x, the proper algebraic way of saying it is function of x, which basically just means your output is going to equal whatever you did to the x in that equation. And then I can also graph a function. Now these are all different specific things, but those are just ways of representing it. Function notation, if you look at these two things, are basically the same exact thing except for the fact that a function notation says f parentheses x will give you 3x minus 8. Basically, all they're wanting to know is what would x do to the value of the output? Well, it depends on what you put in for x. An equation uses y equals. But they are basically one and the same. The only difference is that function notation is a way of writing an equation with f parentheses x instead of y equals.
Yes.
Okay? If I asked you to determine the relationship between the x and y values, it means that what I'm asking you to do is to write an equation, to write the function that created this relation where the y's and the x's are related to one another. Probably the best way to do this would be to write that table so that you could see the relationship vertically. Now, some of you guys may like it this way. I like to see it this way. That's just the way that I am. So I would write down, what are all the x values? 1, 2, 3, and 4. 1 goes to negative 2. 2 goes to negative 1. 3 goes to 0. And 4 goes to 1. Can you find the equation, the relationship that created this, just like we just did? So some of you guys may see the pattern. You may immediately look at it and go, oh, how did I get from 1 to negative 2? I minus 3. And that's the same thing as from 2 to negative 1, and from 3 to 0, and from 4 to 1. If you figured that out by looking at it, then you know your y value is going to be whatever x is minus 3. However, not everybody could see it that way. So the steps to figure it out is you want to know what number goes in front. Now remember, we've talked in years past, you guys talked about y equals mx plus b. That is actually the relation, the function of a line. So if you kept that in your head, what you could do is ask yourself, well, what is the change of y? Because the m is going to be the difference of the y's, -2 minus -1, over the difference of the x's, which would be 1 minus 2.
I got times 2.
And that gives you -2 plus 1,
That's
which is
-1.
-1. And 1 minus 2, which is -1. And that's +1. That's the one that goes here. So if you already know it's y equals 1x, now you got to figure out what the last part is. And that's where you go 1 times x. So 1 times 1 is 1. How did I get to -2? Oh, you minus 3.
I did the 3 and the 0
So if I was to write these as a table of values, I would write 1, 2, 3, 4, and then 3 goes here, 6, 9, and 12. Without looking at the crazy function equation formula, the change of y, the y subtraction. Can you see what you're doing? So that one you recognize, oh look, I did times 3. Your y is equal to whatever x was times 3.
Ooh.
Now you're going to, from this, we're going to go on to this example and look at the last couple of things on this unit section. You're going to be also given word problems or situations in which you are supposed to identify the independent and the dependent variable. The dance committee is selling tickets to the fall ball. The more tickets they sell, the greater amount of money they have to spend on decorations. What is the independent variable? And what is the dependent variable? The amount of money they can spend on decorations depends on the amount of tickets they sell. So the independent variable is the amount of tickets they sell, or the tickets, and the dependent variable is the amount of money they can spend on decorations. What about the next letter B? Generally, the average price of going to the movies is steadily increasing over time.
Ooh.
Okay.
No, it's the movie.
We know that the price depends on the amount of time that passes. Because the more time that passes, the more money we have to pay for it. Example 3. So now we have two different things. Thing 1, tell me who the independent and the dependent variable are. Thing 2 is to write an equation in function notation, kind of like we just did. A lawyer's fee is $200 per hour for her services. What are the different variables? This is asking you basically how much money you're going to pay. So you know that the amount of money you pay total will depend on how many hours that you are asking for the lawyer's services. So the hours are the independent variable because that is what the money depends on. Right? And then you're going to be able to, if you put it in function notation, you could say f of x, or if you want to say y equals, it means the same thing. The cost that you're going to have to pay is going to equal 200 multiplied by the number of hours. That is the function notation. The cost you will have to pay is going to be equal to $200 multiplied by the number of hours. When you see the word per, that means you're multiplying that, because 200 per hour means 200 times the number of hours. The amount of money that I am going to spend at the carnival, which we shall call y, the amount of money depends on how many carnival rides I go on. I know for a fact that I'm going to have to do what? What am I going to have to pay for sure?
$8.
$8. So your cost is going to be the $8 plus $1.50 per ride. Each ride costs $1.50. You're going to spend $1.50 times the number of rides just on rides. Who is dependent and who is independent?
Dependent is
Good. The money depends. The total amount of money is the independent. Total amount of money, is the dependent because it depends on
How many runs?
the number of rides. So the number of rides is the independent variable, and the total money is the dependent variable. What this is saying is they want you to evaluate. The word evaluate means find the value of. So they want you to find the value of this function, this equation, if you know that the parentheses, the x is 2, for example. So you're right. The f of 2 is going to equal negative 4 times, now I'm going to put 2 in x's place, plus 7. That's going to give me negative 8 plus 7, which is negative 1. So the function of 2 is to give me negative 1. If the input is 2, the output is negative 1 based on that function. For letter B, it's asking you what is the function of negative 3 plus 1. So that means you're going to plug in negative 3, find the value, and then add 1 to that. The function of negative 3 is going to be, because we're using this function up here, the function of negative 3 is going to be equal to negative 4 times negative 3 plus 7, because that's what the function equation is. That gives me 12 plus 7, which is 19. Now, they don't want just the function of negative 3. They want to know what the function of negative 3 plus 1 is, which is 20. Now, if I was to try, yep. So, if we look at this, h parentheses y. Another fancy way of saying, if you know that the equation uses the letter y, and oh, by the way, here they're telling you that y, h parentheses y, h parentheses y is 4, all they want you to do is take the 4, which is really the y, and plug it into the y. Okay. So then it's 3/4 times 4, because that's what y is, minus 3. And 3/4 times 4, 4 divided by 4 is 1. You get 3 minus 3, which equals 0. So that means that when y is equal to 4, you plug it in, and you get that it's equal to 0. So now they're asking, well, if this is my function,
Okay.
if that's the function, what is the h of 12? What would I do? So
That gives you
you're going to go 3/4 times y, which now we know is 12,
12,
and then minus 3. 3/4 of 12.
8,
4 goes into 12 3 times, right?
109,
3 times 3 is 9, and then minus 3 is
6.
6. So the h of 12 is 6. Before the independent practice, this is the last example. Manuel has already sold $20 worth of tickets. He has 4 tickets left to sell at $2.50 per ticket. Write a function to describe how much money he can collect from selling the tickets. Well, if we know that he already sold $20, that means he has $20 already in his bank that he made. He has 4 tickets left, so that means I have a total of 4 tickets that I could sell at $2.50 per ticket. So the amount of money he's going to make total is going to be the $20 that he already has plus $2.50 multiplied by the number of tickets. The fact that they said to you he has 4 tickets left means that when you go to plug in to find the domain and range, your reasonable domain and range means what happens if he sells 0? What happens if he sells 1? What happens if he sells 2 or 3 or 4? But you cannot put 5 in here because he doesn't even have 5 tickets to sell. So the function equation would be the equation that tells you, in this case, how much money he can collect. Let's say that is y. And that amount of money he can collect is going to equal the $20 that he has plus the $2.50 multiplied by the number of tickets he sells. But reasonable domain and range, it just wants one list of X's and Y's. So what you do is you recognize that if he only has 4 tickets left, that means you can either sell 0 tickets, 1 ticket, 2 ticket, 3 ticket, or 4 ticket, because this is the independent variable. And then you plug it in to figure out, well, if he sold 0 tickets, he only made $20. If he sold 1 ticket, then he's going to make $22.50. If he sold 2 tickets, then he's going to make $25. If he sold 3 tickets, $27.50. And if he sold 4 tickets, it would be $30. So the reasonable domain is going to be, you would write the following. So you would write domain, and if you recall how to write the domain, we just list all the X values, 0, 1, 2, 3, and 4. And the range would be all of the Y values that we calculated, 20, 22.50, 25, 27.50, and 30.
What if someone steals?
Your job is going to be to make sure that you can answer all of the different types of questions that we just went over. You're going to be working on the independent practice, which are these guys here. It's a total of 7 questions. It's not that many. Just make sure that you can remember how to write the equation, independent and dependent variables, writing a function notation, evaluating a function when you have different values, and then being able to discover a function equation based on a situation is what the last part was.